So in today's session, we're going to move forward with moments, and we're going to be looking at resultant moments. In the previous video, in the previous session, I ended on an example where we had moments moving in two opposing directions. We had 10 Newton meters clockwise, and we also had 12.257 Newton meters anti-clockwise. And I spoke about how one of those needs to overcome the other. Unless they're in equilibrium, one of those directions is going to be larger than the other, and we'll use a resultant moment to demonstrate that. The phrase resultant moment should remind you of what we looked at in year 12, where we were working with forces and we had to regularly find a resultant force. A resultant force was when we considered all the forces acting on a body, including their direction. So we looked at them as vectors, where the direction was important. So here we have three forces on this body. We need to consider or choose a positive direction. So we'll say right is the positive direction. So we've got 10 and 5 newtons in the positive direction, and we have 12 newtons in the negative direction. Altogether, the resultant is positive 3. When we consider all of the forces at play and which direction they're moving in, which ones cancel each other out, we're left with 3 newtons, positive 3 newtons. 3 newtons to the right. We need to make a similar consideration with moments. Instead of having right and left for the positive directions, or up and down, as you might have seen before, we have clockwise and anti-clockwise. We'll choose clockwise as the positive by default, and we'll choose anti-clockwise as the negative. So, in this case, we have 10 minus 12.257. Our overall resultant moment is negative 2.257. We need to say what direction this is, so we'll use the magnitude and the direction to say we have a resultant moment of 2.257 Newton meters anti-clockwise. So this is the resultant moment. The anti-clockwise direction won out of the two moments that we had. The overall turning effect is going to be an anti-clockwise turn. Okay, so let's have a look at a few examples and where these resultant moments are going to come up. So in this first instance, we've been given a diagram and we've been told that it shows, and we've been told that it represents a set of forces acting on a light rod. The reason we're told the rod is light is that we don't need to consider any weight of the rod. We're asked to calculate the resultant moment about the point P. Okay, so there are 3 forces. They're going to produce 3 moments. We just need to take their clockwise ones and subtract the anti-clockwise ones. So we'll treat the clockwise moments as positive and the anti-clockwise moments as negative. Okay, let's first decide which is which. So the clockwise moment, the only one here, is 5 newtons. If I put my finger on P and imitated that force, it would turn the light rod, the horizontal light rod, in a clockwise direction. Whereas the other two will turn it in an anti-clockwise direction. So I'll quickly label these. It'll be sensible for you to do this, especially as the diagrams get larger and more complicated. Clockwise, anti-clockwise, anti-clockwise. Okay, now let's generate those moments. So once again, using the correct notation, we're going to take moments from P. Firstly, we'll start with the clockwise, which is 3 meters away. So 3 times 5. And then we'll go for the 4 Newton force, which is just 1 meter away. So I'm going to subtract 1 times 4. And then the final force is 3 newtons, which is also 1 meter away. I'm going to subtract 1 times 3. Okay, 15, subtract 4, subtract 3, gives us 8 Newton meters clockwise. So positive 8, 8 Newton meters clockwise. Just being careful to choose which direction each of these moments were going to be going, and then taking clockwise as positive and anti-clockwise as negative, and just summing them together. So here's another system drawn out. This time round, we have non-perpendicular forces. So we've seen what to do to deal with these. We need to model the perpendicular approach. We need to model the perpendicular distance from the line of action of the force to the pivot point. Before we get there though, let's just make sure we know which direction each of these forces is going to turn the light rod. So 5 newtons, if we were to imitate the direction that that's moving, that will be going clockwise. Both the 4 newtons and the 6 newtons are anti-clockwise. Okay, so let's just quickly label that so you know exactly which forces are going to be positive and which are negative. We're not going to guess, we're going to know which of them is which. Okay, let's find the perpendicular distances. So we'll start with the perpendicular distance to the 4 Newton force. Here we see that we've made our triangle, our right angle triangle. It's going to be 3 sine 40. 3 was the hypotenuse. We're working with the opposite side, so it's sine, and the angle is 40. 3 sine 40. We'll do the same thing, finding the perpendicular distance to the 5 Newton force. And this time round, the hypotenuse of this right angle triangle is 4. It's the opposite once again, so it's sine, and the angle is 80. So 4 sine 80. Okay, we've got the perpendicular distances for each of those forces. We should be able to take our moments now. This is the length that we need to use, that's the perpendicular distance. And the moment is going to be that perpendicular distance, 4 sine 80, multiplied by the magnitude of the force, multiplied by 5. So that's our positive clockwise moment. The rest are going to be anti-clockwise, so we're subtracting. This one's easy, it's already perpendicular, it's 3 meters times the 6 newtons. A straight 3 meters across, magnitude of the force, 6 newtons. Okay, we're going to subtract this one as well. Perpendicular distance, 3 sine 40, and we multiply that by the magnitude of the force, multiplying it by 4. Really, all of this should just go into our calculator now, all in one nice line, and we get negative 6.02 Newton meters. That is 6.02 Newton meters anti-clockwise. Okay, always stating the direction of the overall resultant moment. And just before we wrap up here, I just want to show you how that little bit of knowledge and technique around resultant moments could easily turn into a problem-solving question. So here we have another diagram that shows a set of forces acting on a light rod. The resultant moment, about P, we're told is 3 Newton meters anti-clockwise. We need to find the length of D. Okay, let's just do the things we would usually do. So, start by labeling the clockwise and the anti-clockwise. And then we're actually going to generate the moments. Clockwise as usual, and taking moments from P. Here the distance is D, magnitude of 5 newtons, 5D is the moment. We're going to add on the other clockwise moment, distance of 2, magnitude of 4, 2 times 4, we already know that's 8. And finally we're going to subtract the anti-clockwise moment. So, it's a distance of 5, magnitude of 4, we are subtracting 5 times 4. We're told that the resultant is going to be 3 Newton meters anti-clockwise. So here it is. You have to set this equal to negative 3. A lot of students here would just set it equal to positive 3. They're not paying attention to the anti-clockwise. So set it equal to negative 3. And after that, you can look and we just have a linear equation. We just need to do some rearranging and solving. 5D equals 9. D equals 9 over 5. D is going to be 1.8 meters. That's the distance that we didn't know to begin with. That's the distance that would give this system an overall moment of 3 Newton meters anti-clockwise. Okay, Vicky, we're just about finished. But before you move on to some practice questions, let's take a look at the specification and exactly what it is that students are expected to be able to show. Exactly what the examiners are anticipating you'll be confident in. While you read through, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date. Maybe come back in 2 or 3 weeks as a refresher or just before an assessment. And as you watch through the second time round, the third time round, because you've done your practice, a lot of what you go through here should resonate with you much more, and you have a chance to really embed your understanding of the difficult topics, anything that's been flagged up as A star.